Hurricane Beryl, an unprecedented indicator of global warming. In addition to causing destruction in several Caribbean states, Hurricane Beryl is drawing attention to the impact of climate change. With a maximum sustained wind speed of around 160 miles per hour, 257 kilometers per h, it made history by being the first Category 5 Atlantic hurricane in almost a century of records. Actually, Storm Emily on July 16, 2005, was the only known instance of an Atlantic storm of Category 5. Since the origins of particular storms are sometimes complicated, it is challenging to fully link specific instances to climate change. However, a major contributing factor to Hurricane Beryl's extreme force is thought to be unusually high sea surface temperatures. Typically, these powerful storms don't form until much later in the season, following the summertime warming of the oceans. In order for hurricanes to have a probability of developing, the sea surface temperature usually needs to be at least 27 C. The waters in Hurricane Beryl's route have been unusually warm for this early in the season, as the map below illustrates. When all else is equal, stronger hurricanes result from warmer oceans because the energy gathered by the storms allows for faster wind speeds. According to US Assistant Professor Andra Garner, we know that as we warm the planet, we're warming our sea surface temperatures as well. And we know that those warm ocean waters are a critical fuel source for hurricanes. The ocean heat content, or the energy stored throughout the water column, is at levels not typically observed until September in the major Atlantic storm development zone. Since the sea surface is normally at its warmest around the end of summer, that is usually when the Atlantic hurricane season is at its busiest. The graphic below serves as an illustration of this, with each big hurricane between 1940 and 2024 represented by a dot. You can see that most significant hurricanes occur in late August and early September. Earlier hurricanes are quite uncommon. Even though a Category 5 hurricane has never occurred this early in the season, its power is consistent with the larger picture of how hurricanes are evolving in response to global warming. Although the number of hurricanes has not been rising, as temperatures rise, a greater percentage of them are predicted to reach the highest classifications worldwide. Hiroyuki Murakami, a research scientist at NOAA's Geophysical Fluid Dynamics Laboratory, says, "Our climate models suggest that the mean intensity of hurricanes will increase in the future due to enhanced global warming, though it is uncertain to what extent climate change contributed to the early formation of Hurricane Beryl." This year, one more thing to think about is local weather patterns. El Niño conditions have recently ended in the eastern Pacific. Because El Niño modifies atmospheric airflow, it prevents powerful hurricanes from forming in the Atlantic. La Niña, the opposite phase, favors the formation of Atlantic hurricanes. There are currently neither El Niño nor La Niña or neutral circumstances. However, later in the year, La Niña conditions are anticipated. There are worries that even stronger hurricanes may form later in the season as a result of this anticipated shift and the rising water temperatures that are expected to persist into July and August. Co Barrett, the Deputy Secretary General of the World Meteorological Organization, states that Hurricane Beryl sets a precedent for what we fear is going to be a very, very active, very dangerous hurricane season, which will impact the entire Atlantic basin. The US Weather Service, NOAA, issued a warning in May indicating that an extraordinary Atlantic hurricane season would occur, predicting 4 to 7 major storms with winds of at least 111 miles per hour between June and November. 3 significant hurricanes make landfall in the Atlantic each year, on average. Quick escalation in intensity. The speed at which Hurricane Beryl strengthened has also drawn attention from meteorologists and climate scientists. A tropical depression with maximum sustained wind speeds of 38 miles per hour or less might become a major hurricane, meaning above 111 miles per hour, in approximately 42 hours. according to Shuyi Chen, an atmospheric science professor at the University of Washington. What makes Beryl particularly notable is that it intensified the fastest from a tropical depression to a hurricane of any Atlantic hurricane in June or early July. One instance of rapid intensification, a situation in which maximum wind speeds rise very quickly, is Hurricane Beryl. Due to the short preparation period, communities may find it particularly unsafe. These rapid intensification occurrences in the Atlantic seem to have become more frequent and larger in recent decades. Dr. Garner states, Beryl, as unprecedented as she is, actually very much aligns with the kinds of extremes we expect in a warmer climate. We're basically stacking the deck against ourselves as a result of global warming, increasing the likelihood of extreme events like Hurricane Beryl. We must cut back on our emissions if we want to change that narrative.